All right, there is one transformation I did not talk about, and it was reflections. Reflections to me, my brain always puts those in separate categories. So maybe y'all's brains doesn't do that, but mine does. So I'm going to show you the reflections now. The reflections basically are like, okay, let me go back to Desmos real quick. What would happen if I plugged in a negative right here at this bottom? So we know what happened over here. This 1/2 squished it. This +2 makes it move to the left 2, and this +3 makes it move up. Well, what happens if I put this negative in front? Bam, it flips over. So it flips over the x-axis when you put it there. But what happens if I put a negative number where this x is right here? What's going to happen here, y'all? Ready? Bam, flips over the y-axis. So it's kind of one of those things, and I will say, since you can use Desmos in my class, the best way to, like, if you forget a transformation, y'all, use your brain and go into Desmos and play around with it. It'll show you what's going on. So with that, that's what the reflections are on that. So why am I telling you that? Because we're going to have to basically talk about the transformations on this. So let's talk about it. Based on what you just learned, and you may not realize this, but you now have the skills with the videos to answer this. What are the transformations? You ready? The first thing I'm going to do, I want you to label your vertex. Even if it doesn't say you don't have to label your vertex, whatever, I don't care. Label it. Vertex, I'm going to look at these numbers. I know my x's always lie, so that +3 is going to be a -3. And I know when it's outside, it does not lie, so I'm going to take that -7. So with my vertex, I know I'm going to be shifting left 3, and I'm going to go down 7. That is 2 of my, with the vertex alone, you can find 2 transformations. Then it's going to flatten curve by 1/4, Go ahead and put in there the flattened curve so I know you know what the 1/4 is doing. And tell me what number is making the curve flatten, which is 1/4. And then it reflects over x-axis. Reflect over x-axis. And why do I know that? Reflect x-axis. How do we know that, y'all? It's because of this number here. And again, to demonstrate that one more time, reflect over the x-axis. You ready? Here it is. Boom, 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 oops, boom, 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 boom. That's what it means to flip over the x-axis. And if you want to see it on the original one, I'll put it up here on the original one. Boom, flipped over the x-axis. So that's what that means, reflection, x-axis. Let's go ahead and do the next one over here together. I have B. The first thing I want you to do is label your vertex, right? Because that's 2 transformations in one. The x's always lie, so put that +4 down. This one always tells the truth, so put the +2 down. So this is, this is right 4, up 2. And then there's no number technically there, which means there's a 1 there. So there's no stretching going on. There's no flattening going on. There's no reflections going on because it's positive. And that looks like that's all that's happening. That's it. So you see why being able to state the vertex is so important? Because in some of these problems, if you have the vertex, you have the answer. So that's basically it for examples A and B. I'm going to upload this video as a separate one. That way they're not too long.